Today we're going to explore how Powertools for AWS Lambda can ease and simplify the creation of AI agents on AWS. An agent is an autonomous software system that leverages AI to reason, plan and complete tasks for humans or other systems. Amazon Bedrock Agents are a fully managed service that helps you build agents backed by foundation model powered orchestration. We're going to create a conversational agent that can invoke an AWS Lambda function to perform various tasks for our users. And we're going to show how Powertools for AWS Lambda can help you accomplish this. So to begin, we're going to have a look at an agent that I pre-prepared. This is going to be a simple agent that can perform a couple of tasks. We're going to investigate it and then we're going to see how you wire it up into an actual Lambda function. So let's have a look at some of the parameters that you can set here. So one of the most obvious ones here is what foundation model you want to use. I've just decided to use Claude 3. Then you can give some rudimentary instructions to the agent. If you see here, we're describing a couple of the operations that it can do. We can say it can tell the current time, it can greet users, and then it can also do some basic arithmetic. Okay, and then the way that you sort of describe these operations a bit more formally is you take advantage of a concept called an action group. Now, an action group is basically a group of between 1 and 5 functions or tasks or tools, as they're called, that the agent can perform. So we're going to click in here and we're going to have a bit of a deeper dive into what these actual tasks comprise. Here we see that this is backed by an existing Lambda function. So you select here, so you can select any Lambda function that you want. This is the one that I've chosen that has the business logic that we care about. And then you basically define different functions for each operation that you want to perform. So for the first one here, get current time, it's fairly obvious what it does. It doesn't take any parameters. Then we have greet user, that's the second function. This, however, does take one parameter. The parameter is called name and it's a string. And then we've got a more complex operation here, and this is the simple calculator that we have. It takes 3 parameters. So A, B are of type number. So they're obviously the numbers that are going to either be operated on. And then operation is the string that describes the operation. So as we can see here, add, subtract, multiply, or divide. Now, before we start, something to note, and this is a little gotcha that can catch you out, is you need to set the requisite permissions on the Lambda function. So you need to allow the Bedrock service to be able to call the create or the invoke function action. So what I've done here is I've got the correct principal, and then I've just scoped down the resource condition so that only the agent, the specific agent, can invoke this Lambda function, just following the usual best practice principle of least privilege that we recommend for all AWS resources when you're creating policies. So if you don't do this, this won't work. So just a little gotcha to take note of. After that, what I'm going to do is I'm going to show you what this Lambda function would look like if we didn't use Powertools. And this will we'll be able to compare and contrast and see some of the benefits that we're getting by using Powertools. So here is the sort of bare Lambda function. So we see we've got a couple of functions here: get current time, greet user, simple calculator. And the thing that drives all this is the event that Bedrock sends to the Lambda function. So that this event here that the handler has access to. And the things that we're really interested here are the function name and any parameters that function has. And then you can see once we've extracted this, what we need to do is we need to figure out where to route that request. So and you'll note that the function name here, get current time, greet user, is going to be exactly the same as the function names that we defined in the action groups here. That's how we sort of identify these things. So we've got this if statement here that's checking each one. We also fall through in case the LLM gives us a function that we don't recognize. I mean, you can already see here that as the number of functions that this Lambda function can deal with grows, this if statement is going to get more and more complicated. So it's just a lot of boilerplate. Something you also have to make sure is that you return the response that Bedrock is expecting, so that's in the right shape. You got to make sure that you get that right. Another thing to know here is that some of these functions. So this calculator here needs to parse these strings into numbers, because obviously they're mathematical operations, so you don't do mathematical operations on strings. So that's another thing that you have to look after yourself. So as I said, there's a lot of boilerplate here, and we can do a lot better than this. So instead, what we will do is we will use Powertools, and we will have a look and see how this can sort of improve and make our code more maintainable. So the first thing that we want to point out here is this Bedrock Agent function resolver. Okay, so this is part of the event handler project package that we have in Powertools. And what you do is you create this resolver, and then you register what we term functions. We term them tools, and you register tools against this resolver. Okay, and you can note from the previous example, so we have this get current time, and here's the implementation. So the first parameter to this tool function is the actual implementation. And you can see that this get current time, it doesn't take any parameters. Greet user. So again, this is the first parameter is the implementation. This takes one parameter. It's called name, which again is the same as the parameter as it is named here, and the same for the simple calculator. These names must match the name that's assigned to them in the action group when you define the agent. This is just an object, and we just destructure the argument names so that we know which is which. So that's just a constraint. Another constraint is that the implementation of your function must return a JSON serializable object, and the reason for that is that the response that we send back to the LLM has to be a string. So what we want to do is to support the complex types like arrays and objects. We want to be able to serialize them to a JSON string and then send them to the LLM. The LLM will be able to understand the JSON very easily. So it just means that you've got a bit more flexibility on what you can return here. You don't just have to return primitives. But I mean, I think the real benefit here is look at how simple the implementation here has become. All that routing logic has now been abstracted away. You don't need to worry about inspecting the function name and trying to send it to the right place. You don't need to worry about the parsing, except for one particular use case. We support integers, numbers, strings, and Boolean values. We will automatically parse them into their respective types when they come, when we get them in the event. However, there's a complex type that Bedrock Agents support, and that's the array type. That is still treated as a string because we can't guarantee the shape of the array. Sometimes it is JSON serializable, sometimes it isn't. If you're using a complex type like an array, you will need to look after the parsing for that in the body of your function. And the implementation there. So that's just a little gotcha just to be aware of. So let's take a look at this actually working. We're going to go into the chat interface, and we're going to try and execute some of these tools. So let's try the simplest one possible. Let's just go, what time is it? And the chatbot should return with the time. So 5:31 p.m. So that's fine, that's the happy case, but of course we all know that errors can happen. So we also have built-in handling for that. So each implementation that you pass here, under the hood, this tool function wraps it in a try-catch. And if we receive an error, we try to send back a well-formatted error to the LLM so that it can give you back some context and say like, hey, this operation didn't succeed. So let's just artificially induce an error here. Just throw a new error, and then we'll deploy this, and we'll try and invoke it. Something to know here is you'll see that I've created a tool with the same name. If you do that, it's basically last one wins. So this guy here is going to overwrite the previous version. This is almost never the behavior that you intended. So we also log a warning message in the CloudWatch logs. So if you see that error, then you'll know that you've defined a function with the same name twice. You probably want to rectify that. But for our case, this actually works out because we want this one to take precedence. So let's get a new session. Let's again try, what time is it? And then this should give us a nice error. So here you go. You say, I couldn't retrieve the current time at the moment, and you see there was an issue in executing the redacted function. The reason why that's redacted is the system prompt under the hood for this agent. It tells the LLM not to reveal any implementation details of the Lambda function that implements the agent handling code. So that's why that's like that. But again, it's still, the error has been handled quite gracefully. You can actually do even more granular error handling. There's some specific error types that you can send back to Bedrock as part of the response. And that's where we use this Bedrock function response class. Okay, and I'll show you now how that works. So again, what we'll do is we will overwrite the current time function again. And you'll see here, we're actually creating this Bedrock function response and returning it. Under the hood, that's how this tool function works as well. Anything that you return back from this implementation function will be wrapped in this type. What we'll do is, as I mentioned earlier, we JSON stringify the response and we put it in the body here. What you can also do is you can pass this response state here. So this again will alter how the LLM responds in the face of this failure. So it's going to try and continue the conversation on and try and get you to do other things. Session attributes is another thing that you might want to update. This is how you persist state across prompts. So you might want to add a little bit of extra information to the session attribute that the LLM can keep in its memory. So again, that's when you want to drop down and use this Bedrock function response, and when you want that more fine-grained control over the responses that you're given to the LLM. So let's just deploy this, and you should see the behavior of the LLM will change now because we've done this reprompt thing here. So this was going on about that it was redacted. So let's just try, what time is it again? No, not again. What time is it? Yes. And then just run. And here, now you'll see. So it's saying, okay, there was a technical issue, but look here, I can still help you in other ways. So it's trying to keep you engaged. Please let me know if there's anything else I can assist you with. And then finally, another sort of escape hatch that we have. You might want to get access to the event and the context. So if you look at all these tool definitions here at the moment, they all take either 0 or 1 arguments. And the first argument is basically an object that represents all the parameters. But you can actually add a second optional argument, and you will see that here. It's second optional argument, and that is an options object that has both the event and the context object that we got from the handler. And as you can see here I'm just logging out the AWS request ID. So you can obviously pluck off any of the fields from the event or from the context object and do whatever you want with them inside the handler of your function there. So again, it's just a nice little escape hatch sometimes when you want a little bit more flexibility. So that is a very high level overview of how these agents work. I think the real win that we have to focus on here is just how simple this handler comes and how easy it is to extend, just purely by adding extra tools. So no if statements, no parsing, it's all looked after you apart from the case of the arrays. So this is just going to be a lot more easy to maintain than the previous version that we saw. So thank you for listening.